So objective. So first of all, we are starting the IPv6 now. Objective, the CCNA covered this chapter include why do we need IPv6, IPv6 addressing, addressing types, special addresses, auto configuration, configuring IPv6 and tunneling. So why, first of all, the question is $1 million question, why we need IPv6. The amount of people and devices nowadays are connecting, increasing every other day. For example, we're now talking about even fridge, freezers, uh, washing machines and all those household things are also connected to the internet. So the problem is if you need to connect to the internet, you need a unique IP. But the problem with IPv4, you have maximum 4.2 billion IP addresses. Whereas nowadays we have trillions of devices may be connected in the next few years as well. But the IPv6, that's why the IPv6, now the problem, IPv4 has just only 32 bit. IPv6 only 128 bits. So 2 raised to power 28. So there are trillion IPs addresses are available. Publicly, you don't need anything else. So now representation point of view, we know the IP addresses are represented in the decimal format and we can convert binary to decimal format. We know the formula. However, the IPv6 addresses are we represent them in a hexadecimal format. Base and is a base 16 number system from 0 to 9 and A to F, right? So for example, in the decimal format, 9, 10, and 15, 15 is the highest number. And binary point of view, 111 is the highest number, and F is the hexadecimal is the highest number. So 0 to 9, and then A 10 will be represented as A, 11, B, C, D, 12, D, and 13. So 4 numbers, half of the byte can be represented with a single hexadecimal value. A digit hex and 8 binary pattern. Look at the binary bits. Here we can see the hexadecimal format. Here we can see 120 bits in length written as a string of hexadecimal value. 4 bits, 1 hexadecimal digits, 128 bit, 32 hexadecimal digits. So you can see most likely we represent the IP addresses on IPv6 in this format. Okay. So very long IP, but let's see, we have few techniques. These are also as well. Hexstat used to refer to a segment of 16-bit or 4 hexadecimal. Okay, 16-bit. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Can be written in the either lowercase or uppercase. So here we can see the hexstat, one of the hexstat can be defined further in this format. Now, IPv6 is very long. When you write the IPv6 is a very big, it look like a very long one. Now, what we can do, we can minimize that size actually. What we can do, the first rule to help to reduce the notation of the IPv6 address is in leading 0 in any 16-bit selection or hexstat can be omitted. 101 can be represented as a 1AB. 09F0 can be represented as 9F0. So you can remove the left mode 0, and 00 can be represented as just AB as well. For example, preferably this is the 2010 dB 0010000000, right? So here you can see 30. We can no leading 0, 201, remove 0, 00A 0, and all these represented as 0 as well. So effectively we can compress them into 201 and in this format. Omitted all 0 segment, known as the compressed format. A double colon can be replaced with a single contiguous string of 1 or more 16-bit segments. So for example, here you can see wherever there is a 20 continuously 0, we can represent the double column. Okay, only one. You can represent the double column only once. So either the double column can be here or here. Okay, may be used. So you cannot write double column. It's an incorrect one. IPv6 not used in the dotted decimal subnet mask. Prefix length indicate the network portion. IP. So as we know, in the every IP in the IPv4 or IPv6, there are two portions of IP. One is the network portion, and the second is the host portion. IPv6 uses the following format: IPv6 addresses and a prefix length. Prefix length can be ranged from 0 to 128, like typical 64. So for example, if you want to assign prefix plus interface ID, example is this. So there are many addresses types in IPv6. Unicast addresses. Okay, unicast addresses can be used globally. Unique unicast addresses, link local addresses, loopback addresses, unspecified addresses, unique local, embedded IPv4. Okay, so these are the IPv4 unicast addresses. Multicast addresses, any cast as well. IPv6 does not have the broadcast addresses. So IPv6, there is no broadcast mechanism. Global unicast mean publicly routable to internet, similar like IPv4. Start with 200, 2000 and double colon /3. So this is how we represent. So /23, as you can see, the registry number, which you buy need to, this is the related to ISP, /32 company related, and /64 is a subnet. Link local addresses like private IP addresses like 110 range, 192 range, and 172 range. They are not routable over the internet. Start with FE80. Okay, there we go. Special address is 000 equal. This is equivalent to IPv400 and is typically the source address of the host when you are using stateful configuration. Equal to 127 IP address, which is self IP assignment and testing. This is known as IPv4, would be written in the mixed IPv4 and IPv6 environment. This is the unique local range. Special address is FF00 multicast range, reserved for example in documentation. Also reserved for example in documentation. Use 6 to 4 tunnels. So how we can configure them?